Hi, it's January 16th. This is the lecture on week 2 of Programming Foundations in Python. Let me touch real quickly on some of the topics that will be covered here. First topic that covered is object-oriented programming. And if you're not familiar with what object-oriented programming is in general, it's basically when programming, it's organized around objects rather than actions, and organized around data rather than logic. In the past, programming has been viewed as a logical procedure that takes data, processes it, and then puts it out. Object-oriented programming instead focuses on the data rather than the logic behind the programming. So that's what's going to happen in lesson 6. Then in lesson 7, get onto standard library and Python packages. Python, being an open source tool, has a standard library which was created by the inventors of Python, some basic functionality, but then there are a whole bunch of other libraries which are created by users and made available to everyone. And this is where the power of Python kicks in, but it's also where the messiness kind of kicks in too, in that anybody can put a library out there or functions within a library, or create a function and put it in a library, and they can call it whatever they want, and it can do whatever they want it to do, and they can say it does stuff, and it may or may not do what they say it does. So you run the risk of, when you call up a function, it may not do what you think it's supposed to do, and you may not have access to under the hood, if you want to call it that. So there's a ton of power in that, but there's also some difficulty with maybe documentation isn't as clear as it needs to be, or like I say, the functionality might not be exactly what you're expecting it to be, and you might not even know it's not what you expect it to be, depending on the complexity of the function you're trying to call up. You have to have a little caution there, but there's a whole vast world of possibilities based on the standard library in the past. Next chapter talks about inheritance and polymorphism. Now, these are concepts within programming. Well, let me talk about the concepts of inheritance and polymorphism outside of programming. Inheritance is what you get from your parents, the attributes you get from your parents. They could be physical attributes, they could be mental attributes, emotional attributes, they could be just about anything. You see physical attributes is a great example. You see a lot of people who are tremendous athletes, maybe world-class athletes, professional athletes, that are the children of other professional athletes. They've inherited a lot of those physical attributes. So that obviously is inheritance. Polymorphism, on the other hand, is when as a child you're able to add new or different or more attributes to your makeup. So the same thing goes on with objects in programming. There are objects that are children, or what's another good word for it? I don't know what. I just call them children and parent objects. Children objects that can retain a lot of the same attributes the parent objects have, and that's called inheritance. And adding new attributes to those children objects is called polymorphism. So there's a lot about that, explaining what that is and how it works and how it can benefit your program. After that, we get into a project. Before the project is a lesson on debugging. If there's any one skill that a good programmer has that a that an unskilled programmer doesn't have, I would have to say it's not all the depth of knowledge of certain little idiosyncrasies of the programming. It's the ability to debug. If you can debug, if you can fix stuff that's broken, if you can make stuff that's not working start to work, then you are a successful programmer, regardless of what the level of and depth of your knowledge is in any particular thing. So a good lesson on debugging is coming up this week. And then the last lesson, of course, is the final project, where you're asked to put together a program that will execute things that are requested in the final project. So as you get to that, you'll see what that's all about. Python, I've told you this before, I'll tell you it again, it is not my strongest suit. I've survived as a data scientist for 25 years, learning how to use scripting languages within statistical software packages, and dabbling a little bit on the programming end of things with Python and R. but not having done a whole bunch of that. So why are we covering it? Well, as I look at job openings for data analysts, business analysts, junior data scientists, data science managers, all of these, not all of them, but most of them say, hey, you should really know Python. So Python's a very multiple purpose, multi-use type of language out there these days. And just, if you can do it, you're ahead of where you would be if you couldn't. So that's why we cover it here. Okay. If you have questions, Angelina is a great resource for questions. We have lots and lots of programmers around here that can help answer questions and figure stuff out with Python. I, frankly, am not one of them. My strengths lie in the statistical analysis realm of the data science work. But I'm learning, I'm getting better, and we will give you the help you need. So keep working hard. There are no other attendees on, so it won't be a Q&A session, but keep working hard, ask lots of questions, and dedicate the time necessary, and you'll have success in this program. Thank you. Check back with me later or talk to you later. Bye.